Okay, solving an equation involving logarithms on both sides, problem type 1. As the title mentions, for this exercise we are going to have a logarithm on the left side and also on the right side of the equation. And we see that clearly. We have a logarithm base 5 of x plus 1 on the left side, but on the right side I also have a logarithm. On the right side I have the logarithm of 1 plus log 5 of x minus 3. So the trick to this exercise is to take all of the logarithms to one side. I can choose to either move both logarithms to the left side or leave them both on the right side. In this case, I'm just gonna leave it all in the left side. To do that, I gotta move this to the left side. If I have it here adding up, I will have it here subtracting. So let us do that. I have a logarithm base 5 of x plus 1 minus logarithm 5 of x minus 3. That is equal to 1. Here I have a 1. Oh, yeah, 1. Um, I do that because when I have them on the same side, in this case the left side, I can apply the properties of logarithms. And here, note, I have a minus sign and I have two logarithms of the same base. So what rule can I apply here? Remember the rule of the quotient. Whenever you have logarithm of one number, for example 5, minus logarithm of, for example 7, you can write it as the logarithm of 5 over 7. We saw that in the previous model. And I see that here, so I can apply that rule here again. So I can simplify this as just one single logarithm, which is going to be the logarithm base 5 of x plus 1 on the numerator over x minus 3 in the denominator, and that is going to be equal to 1. Now I have simplified this into one single logarithm, but still I don't have x alone. What is preventing me from having x alone here is the logarithm. How do I get rid of logarithms? Well, by moving it or taking it to the exponential form. So take it to the exponential form. I want to write this as the exponential by taking the base, which is 5, the exponent, which is 1, and the result, which is this whole argument. Okay? So x plus 1 over x minus 3. And that way I no longer have logarithms in my equation. So it's a little bit easier, right? This just comes down to a regular rational equation. And you've done this before in previous models, so this shouldn't be no problem for you. How do you do that? Well, first you want to take the denominator to the left side. How do I do that? Well, multiplying, because it is dividing, so I'm gonna move that. Multiplying. Then I do the multiplication here. I do the distribution, so it's going to be 5x minus 15 equals x plus 1. Okay, I now have 2x. Here one and here's another. What I want to do is leave x on one side. I can either take it to the left side or to the right side. Just for easiness, I'm gonna leave it on the left side. 5x minus 15. And I'm gonna take this to the left side. Minus x equals 1. Okay, I have a term here that does not belong here. Why? Because it does not have an x, and I want things with x on the left and things without an x to the right side. So I'm going to move it to the right side. It's a subtraction. So when I write it on the right side, it's going to be an addition. Now I'm just going to simplify. 5 times x minus x, it's 4x. And 1 plus 15 is 16. Okay, easy, right? Last step, I'm gonna take this 4 out of here. I don't want it here. X is 16 over 4. 16 over 4 is 4. Just like that. So I just write here 4. I write here the 4. And that's the solution to my exercise. Alright, let's try another.